Hello everyone, my name is Fazeel Ahmed and welcome to the Multiphase Heat Transfer and Fluid Flow course. I will be following the book Nuclear Heat Transport by Al-Wakil, and these are some of the other books that I will be taking stuff from. And as I take stuff from them, I will mention what book I am using. This video is going to be an introduction of the subject, the basic concept of what it means to be two-phase, and well, it is going to be my warm-up as well as yours. So let's start, shall we? What is heat transfer in its simplest sense? Heat transfer in the simplest sense is this problem. Here we have a solved example. In the pipe which has been given, some fluid inside it is flowing with a given velocity. It may be anything from air, helium, water, steam, or liquid metal. Due to some external conditions, there is some heat either being added to this pipe or removed from this pipe. There will be various methods of heat addition, like flux control method of the solar radiation, or a fixed surface temperature maintained by some other substance. For a problem of heat transfer, we have to be able to relate the following parameters to each other: the temperature difference across the two ends of the pipe, the heat flux from the outside, the velocity of the fluid, the thickness and the material of the wall, the properties of the fluid moving through, and be aware of the temperature profile throughout the thickness of the wall as well as the temperature profile in the fluid. This is what we already know how to do in basic heat transfer courses. Now we go one step beyond. What if we have a mixture of a gas and a liquid flowing through here? What if liquid flows in the pipe and only vapor comes out? What if liquid goes in and a mixture of liquid and vapor comes out? And even vice versa. What if vapor flows in and liquid starts to come out? How would these factors affect our temperature calculations? This is what we call two-phase heat transfer. This is much more difficult than the basic heat transfer courses, so buckle up. We are in for a ride. Similarly, our knowledge of fluid flow in the basic courses is only limited to single phase. We can only calculate the pressure drops if we have the liquid flowing through the pipe or vapors flowing through the pipe. This course we will start to learn stuff like how to treat a mixture of liquid and vapor moving together and their impacts on the system. I would include one last thing in this zero lecture. Why are we studying this? Well, the applications of the book I am following is nuclear. So if we look at a nuclear perspective, in the boiling water reactors, the coolant has to go through a phase change. It has to flow in as a liquid and boil and convert into vapor to run the turbine. We have to know how much heat that two-phase mixture will take with it. Similarly, in pressurized water reactors, we sometimes want localized boiling due to heavy loads, or even bulk boiling in the case of emergencies and some transit conditions. We have to know the exact mechanisms of how these processes are going to take place, and what will be the temperatures and the heat transfer coefficients all over the reactor, how many bubbles are going to be formed, how is it going to affect different system parameters like the moderation. We study two-phase flow because a phase change process helps us remove or add vast amount of heat, much more than the single phase flow. So this is something we want to utilize and hence have to learn. However, as much advantageous this is, it is also complex and dangerous. You can search other examples of the two-phase flows and put them in the comments below. The course will be streamlined, everything will be covered along the lines of the book mentioned in its own time and at its own pace. So, wish me luck as I embark on this oh so difficult of a task. Hope you persevere with me. That's all for the introductory lecture. I am Fazeel Ahmed. Stay safe, stay hydrated, remember to smile, and I will see you in lecture number 1. Bye.